Hey guys, we're going to do lesson 10, day 4, which is on rearranging formulas. When you don't have so many numbers, it's more about the letters that are in there. Still talking about how you use properties of algebra to solve problems. Let's go ahead and do the intro tasks together. So in this one, solve each equation for x. Remember, in this problem, we want to get x by itself, and so I do this as I see students need it. We might use this like a lot all the time on this problem. So first of all, I'm going to imagine that there's a left side and right side to the problem. And what happens on the left side must also happen on the right side so things stay balanced. It's like a scale and things have to be, weighed the same. So in this problem solving process, step 1 is going to be, well, get x by itself. Two-step problem, maybe you know what to do, but I'm going to start with adding 6 to both sides. That way, I'm focusing on the side with x, and I'm going to get rid of the things that are on the same side with it, like how there's a minus 6, and subtraction is a weaker thing than multiplication by 2. So I'm going to get rid of the weaker thing first, the outer friend type of thing, and move towards the close family unit that's right there next to x. So we're left with 2x equals 16. Last step, get x by itself. Currently there are 2 of them, and if we use division, you can get rid of the 2. And that goes to both sides. Notice that I'm not putting x right there. It is not using x in the bottom. X stays where it is. That way we're left with the x, and it equals 16 divided by 2 equals 8. We can check if this is actually a solution by taking the 8 and putting it back there where the x is located. So 2 times 8 minus 6. Following the order of operations, 2 times 8 is 16. And then 16 minus 6 is actually 10. So it does line up. We have 10 as our answer. Okay, continuing on with the problem. We have part B. So in part B, again, I like the idea of a left side, right side, so I want to see that. And a little less explanation, maybe just like showing the 2 steps, is first of all, add 3. Because it doesn't have an x multiplying it, add 3 to both sides. And rewrite. Negative 12 plus 3 means you're going to get closer to 0, so negative 9. And now divide by negative. Divide by negative 3. Again, do not put x down there. It's just the number, the coefficient that's multiplying x. A negative divided by a negative is a positive. 3 divided by 3 is 1. A negative divided by a negative is a positive, and 9 divided by 3 is 3. So x equals 3. We could check that if we take the 3 and we put it back in the formula. So negative 3 times 3 minus 3. And then we simplify, so this becomes negative 9 minus 3. And absolutely negative 9 minus 3 is negative 12, which is what that is. Okay? So checking it, solving and checking is the name of the game. All right, we've practiced this with numbers. Hopefully you should see the comparison is what we're going to do here as well. In the first step, we have to get rid of the thing that is not next to x. We have to get rid of b. So step 1, again, I like the left side, right side. Oops, drop, there we go. Right side, left side. Step 1 is going to be get rid of the thing that doesn't have an x multiplier. So we're going to get rid of the b by adding its opposite. That means negative b plus b cancels. We're left with ax equals. And you might be struggling right here thinking that what is c plus b? And sometimes people say that c plus b equals cb. Well, guess what? That is 100%, draw it please, not true. It's not equal. This is a hidden multiply sign, and I mean, I hope it's obvious, but addition is not the same as multiplication, right? 2 plus 3 is not the same as 2 times 3. So, which is what I could put right here. 2 plus 3 is not the same as 2 times 3. So instead, I'm just going to rewrite it. I'm just going to write it as c plus b. That's fine. That's totally okay to do. Next step is to make sure that x, right now there are a of them. Like in this example, there were negative 3 of them. In this one, there are a of them. And to make the a go away, use division. Everything is divided by a. That makes a divided by a cancel, because it's 1. And so we're left with x equals c over a plus b over a. Or, if it helps, you could write it as c plus b over a. Both of those are the right answer. And yes, plugging this thing, or maybe even this thing, back where the x is, does give you a true statement. Let's check it out. Here's my, I don't remember. Okay. If I take x and I write a, because that was a from the formula, c plus b over a minus b. What happens to the a's? Well, 1's on the top, because it's technically over 1. 1's on the bottom, so something on top, something on bottom in a fraction, they'll cancel. You're left with c plus b minus b. Those b's, now I can focus on how it's b minus b. So they'll cancel, and we're left with, oh look, the left side and right side of the equation are the same. Solving and checking. Okay, here we go, getting the classwork. Not yet. Not yet. Compare your work in parts A through C. Did you have to do anything differently to solve for x, and why is this like not easy to write on? Okay, so really like no, step 1 in part A, part B, and C was all the same. It was undo through the process of addition, undo the number that was added or subtracted to the x term. That was step 1, and then step 2 was to use division. So write it out. Step 1, come on now, zoom in. Like it did it before. There we go, kind of picky program. So step 1 was to subtract, no, add to cancel subtraction. Wow. So we added, and we added. Step 2 was to divide to cancel multiplication. That was the same for all of them. For all of them, we did that. Okay, so let's see here. Solve the equation. All right, so instead of solving for x, let's solve for a, right? What really changes here is just what we're focusing on. They're just numbers. They're just things that we could use. In fact, I mean, not that we do. We could solve for a number in an equation. All right, you at some point need to zoom in. At some point, you need to zoom in. I mean, it is called a pro board, but I think right now it's being really amateur. Haha, dad joke. Promethean. Okay, so let's take this equation. Let's solve for a. In the process of solving for a, there are still some things that we need to commonly do. Like, I should probably draw a line, and I should think about how I want to get a by itself. Well, a is bound up in this little term right there. So anything outside of that, that goes away first. So step 1, oh, looks the same. Add b to both sides. So we have ax equals, remember, a letter plus a letter does not make them smush together. It still has to have a plus sign between them. So c plus b. And then last step, I'm leaving a where it is, and I'm getting rid of x. And so I'm going to divide both sides by x. This is that one time where x goes on the bottom of the fraction, because I'm not solving for it. So if I'm not solving for it, it has to go. And that means I'm left with a equals c plus b over x. Or if you like, the way that I've been writing it, c over x plus b over x. I wrote that. There we go. Okay, box it. There it is. And yes, we can absolutely check it. We can check it by putting in this information back up into the formula, kind of like what we did over, if I'm going to be useful at all, right here, how I plugged it back in. And plugging it back in, c plus b over a, that's the same thing that we would do. We would get things that cancel, and we eventually get a simplified equation where c is the answer. So today's lesson is really about focusing on the letters, not even like concerned with the numbers, and I'm sorry that that's going to trip you up, but that's just the way that it is. We still follow the same principles. Undo, using inverse operations, like the opposite of plus is subtract, the opposite of multiply is divide, the opposite of square is square root. So we're going to use those facts that we're given about the opposite of operations to isolate or to solve for a variable. Here we have solve the equation ax minus bx equals c for x. The variables, they represent numbers. So the reason why I want to do this example too is because x is located in two spots. X is in this term and it's in this term. And the principle that we're going to, address, but do, is because there are two places, we can factor x away from them. Notice that there are two terms, 1, 2, that have an x. And we need to combine like terms. So we can combine like terms by adding and subtracting coefficients. Literally what that means is a is the coefficient, b is the coefficient, subtract them. Subtract because that's a subtraction sign. Okay? So therefore, a minus b is multiplying x, and because it's multiplying x, we will use division. Division will cancel that thing in parentheses, this thing right here, multiplying x. So write it out, a minus b in parentheses times x equals c. Remember that we have two sides of the equation, and when you use division, the thing that goes on the bottom is this expression right here, a minus b, both sides. Okay, now note, that's the answer. I can't split this into two fractions. It's just the one. So x equals c on top, a minus b on the bottom. And there's your answer. Plug it back in. Plug it back in. I have a minus b, that was already there, times, well, this is x, c over a minus b. And when those cancel out, I'm left with c, and it equals c. So therefore, things are still true. Okay, love these questions. Solve for y. First thing, get rid of the parentheses. So distribute. 25x plus 25y equals 65y plus 83. Step one in solving for y is to move the x's to one side, move the y's to the other. And that will happen when you got a choice. You can move either the 25 or the 65. I prefer to cancel the smaller number. That way I have a positive integer when I'm looking at like what this number should equal. So if I subtract both sides by 25, wait for it. If I subtract both sides by 25y, that was weird. And that would move this y to the left, from the left to the right. And I should also get rid of the 83. I can do it all in the same step. So let's use black. Minus 83, minus 83. So right here, those cancel. 83 minus 83 is 0. And if I rewrite, at this level, I'd have 25x minus 83 equals 40y. Remember, there's no more y's on the left side of the equation because I canceled them out. They're gone. There's no more 83 over here because I subtracted it. I did the opposite operation, so it's gone. And now what I have is something where it's 25x minus 83 equals a number times y. How do you get rid of the number that's multiplying y? Division. Cancels. Maybe that can reduce. I don't really care. Division. And I hope you can see that, but I divided everything by 40. All right, my answer, survey says, y equals, I might as well put the y back on the left side so it looks like an equation that we're typically used to seeing. 25x over 40 minus 83 over 40. And done. Okay. Well, not done with the lesson. Here we go. Let's keep going. Okay, next up, example 4. So in this problem, solve for x. Get rid of you. Get rid of you. There we go. Okay, in this problem, solve for x. And so step one should be get rid of the parentheses. So here we go. Step 1. Step 0, draw my line. Step 1 is to multiply, just to make sure that there are no parentheses and we can start moving terms around. And again, the goal after the parentheses is get x's to the same side of the equation. Right here, d times negative 5 makes negative 5d. d times x makes add, let's see, if I want to solve for x. I'll put D in the beginning and X right there. Just an order letter, maybe alphabetical. Okay, equals mx plus, okay, I have to write mx by itself because it's not multiplying anything. Together they multiply each other, but this plus sign separates the rest of this equation from the mx. Now, 9d times negative 3, negative 27d. And because of the minus and the plus, I'm just going to get rid of the plus sign. It's just a giant subtraction. Now, I have u, right? Good. 9d times x, so plus 9dx. That's a lot of letters, a lot of numbers. But remember, the step one that I did was distribution. Maybe you need some practice with that, but that's just basically all I did. I took the parentheses and I just applied what the parentheses are telling me to do. Multiply. Now, I want to take and move x's to the same side of the equation and non-x's to the other. So the first thing that I notice is that this minus 5d doesn't have an x multiplying in there. It's not a factor. So therefore I'm going to add 5d to the left side of the equation and go over to the right and add 5d to the right side of the equation. I also know it lines up. Letter D, 27 and 5, put them in a stack. These cancel. Now these two things, they both have x's in them, so I'm going to, I know that you don't have this power, but I do. I'm going to do this. I'm going to back up. Thinking about it. There's more x's on the right side of the equation. And because there's more x's on the right side of the equation, I should just leave them there. And I should get rid of the thing that's not x and push it to the other side. So it doesn't matter if you do what I started with or you are hitting the brakes and reversing and starting it all over again. The fact is, this is the simpler way to go. I'm also going to have a positive 27 minus 5. I'm going to have a positive number right there. We like positive numbers. Make us feel good. Okay, negatives, such downers. Okay, that means the negative 27 and the 27 cancel. And then I'm going to make sure that the dx is moved to this side with all of these other x's. Subtract it, cancels. I instinctively put it right there, and I wasn't even really thinking about it, but now I'm glad that I did, because this is 9 dx's, and I'm taking away 1 dx, so 9 minus 1, and then the dx things come together. I can't put dx with the mx yet. There's a trick we're going to do. I can't put it over here because the letters don't match. The letters have to match to be like terms. So dx, it's plus mx. It equals 22d. I'm not done. I'm ready for that trick that I described in the previous example, though. And the trick is this term and this term, they're both being multiplied by x. So factor x out of it, meaning take it away, put everything in parentheses with x on the outside. That's factored. It's a term, a math term, that really means split a product into its pieces. So this product of mx plus 8dx has x as a factor. So I'm going to pull that factor out. And then what I'm left with is 22d equals m plus 8d times x. I have the x on the outside, and if I needed to, I could multiply it back in. But all I need to do now is make the thing timesing the x go away. And the opposite of division, opposite of multiplication is division, so bring in the red. M plus 8d. M plus 8d. Answer. Write it nicely. Put the x in the front. 22d over m plus 8d. This will take lots of practice. If you're not good at it now and you're just feeling like so confused about it, like I get it, I understand. The only way through is forward. And so therefore, maybe you need to actually do some practice. This is extra practice. Come get help. Remember, distribute should be your first step. And at some point along the way, you need to get x's to one side of the equation, everything else to the other side, so that you can do, where'd you go? So that you can do the factor step. Don't forget that you need to do that. You need to do that factor at some point, okay? Solve for k, solve for b, extra practice. That is it for this page. Okay, where are we at with pages? I'm on to the next one. Comparing equations with one variable. Okay, so go ahead and pause the video if you needed to. I'm going to keep moving forward. Again, when you watch the stuff that I'm preparing for you, just, watch it in a way that makes it helpful for you. Skip if you need to. Jump ahead in 10-second gaps as you see, like, what did he do? What did he do? What did he do? Don't listen to my voice. Mute it. Okay. Equations containing, turn on the closed captioning. Equations containing more than one variable and a related equation. We want to solve that equation for x. I don't want to do that one yet. I want to do this one. This one looks easier. All right, so step one in this problem is to move the x's to the same side. So to move the x's to the same side, let's add 5x to both sides. By both sides, I mean if there's the equal sign, left side, right side. Now, I should also, because I can do this in one step, I can also make the numbers that are not x go to the other side at the same time. So I'm going to go -4, -4. Everything will be totally okay because I'm adding the same thing to both sides. I'm subtracting the same thing from both sides at the same time with balance. So therefore everything's groovy. -4 plus 4 cancels. -5x plus 5x cancels. And what I have left is 8x, because 3 plus 5 makes 8, equals 2. 6 minus 4, 2. And then last step, divide by 8. X equals 2 over 8. I could call that the answer, but 2's even, 8's even. Cut them both in half. That's a better answer. X equals 1 over 4. Okay. Okay, step one was to balance. Maybe this is a Labrantism, but balance so that both sides of the equation to move x. That's what we're really doing. Balance it to move x. Step two, divide. I'm going to keep those steps and I'm going to do them over here on this problem. I think I'm ready now. And my strategy is, if I don't feel ready to solve a problem that has a whole bunch of letters in it, I should look for a related problem that has a whole bunch of numbers. I feel good about this. I've heard you feel good about this type of problem. So once you feel strong about a number, an equation that has numbers, and you feel like you've got it, and you've got it, and you've got it, then it's time to bring in the letters. So ax plus b equals d minus cx. Step one over there was to move the x's to the same side, and I'm focusing on the subtraction. Add cx, cancels, add cx. The second thing that I did can also happen right here, and technically it's not the second thing, it happened at the same time, and it's two things that happen at the same time. Minus b minus b. That's where I had the -4 show up right there. Okay, rewrite. I also need my left side, right side. So that is terrible. Let's see if we can do better the second time around. Here we go. I'll accept that. Okay, so ax plus cx, I mean, I don't know what those are. I just know that they are x things. So put them together. Ax plus cx. B minus b, gone. Cx plus, negative cx plus cx, gone. And then over here, I don't know what d is as a number. I don't know what b is as a number, so I'm just going to write them out, d minus b. Trick time. Trick from the previous page where you have to split apart this expression. Both of these have an x. Take it out. Put it outside. That's the process of factor. I'm dividing everything by x so that I can then multiply by x. And I'm left with, let's go green, x times a plus c equals d minus b. This step is necessary. It deserves a gold star. This step is, that's not gold. It deserves a gold star. This step is so important because that's the step of factor out x. So I'm going to write it. Factor out x. Like, you have to do that. That's the only way you can get x by itself. If it's located in two spots, factor out an x, and now you have x located in just one spot, and it's multiplying. So to cancel multiply, use division. Use division, a plus c. And you know what? That's gone, and you're left with x equals d minus b over a plus c. That's it. You're done. I should box it. And yes, we could put it back into the equation. Things would cancel. You'd wind up with equality on both sides of the equation. But again, reminder. See if I can zoom out here. Zoom out here is what I want. I want you to zoom so slow. Okay. Balance. So balance was the first thing that we did. There was a second thing, and that's because it didn't necessarily like reveal itself in the numbers problem, but that was the factor. And then last of all, divide to make things simplify out. Okay. Oh my goodness, we got so many of these. Once again, I'm going to solve for x here first. And oh, I see a fraction. Anytime there are fractions, you have to multiply everything by the denominator. So, yep, you're good right there. So multiply by 5, everything times 5, everything times 5. I technically should put the 5 on the front of the 3, but whatever. And I should multiply by 7 times 7. So if I take this thing and I multiply it to the 2x over 5, the 5's cancel. The 5's cancel. And I'm left with 7 times 2. But then I got to reset, and I've got to do, let's go red. I've got to multiply 7 times 5 times x over 7. And in that problem, the 7's cancel. So I'm left with 5x. And then on the other side of the equation is 3 times 5 times 7. 75? No. 105? I think it's 105. I think it's 105 because 15 times 6 is 90, so 15 times 7 is 15 more spaces. 105. Don't at me. Okay. If we add these two things together, they have combined like terms. Technically a factor process. So I'll show it. Let's do it right now. I'm going to factor out x. So I guess I could have done it in that previous problem. What's 14 plus 5? 19. And then put the x back where it belongs. Equals 105. Okay, last step. Solve for x. Divide by the number, multiplying it. Okay, if you can, see the 3 things you have to do. Distribute, which is tough because, well, no, it's not distribute first. It's cancel the fractions. Cancel the fractions by multiplying everything by the denominators. So that means that times 5 times 7, that times 5 times 7, that times 5 times 7. After you've canceled everything by multiplying all the denominators, then you have no more fractions. So factor out the x, which doesn't really have to happen, but it's nice for when I do this one, so you see what I'm doing here. And then last of all, divide. Technically like 3 steps. Okay, here it is. I'm going to multiply everything. Wait, line. Give me some space. I'm going to multiply everything by the denominators. B times D and B times D. Okay, remember what happened here. This is kind of a challenge, but this is what happens. In this BD being distributed to AX over B, the B's cancel. So I have A, D, X. Let's just go alphabetical. That's the only reason why. And then in this step, multiplying there, this has a D denominator. So the D's cancel, which leaves me with B times CX. B, CX. And then on the other side of the equation, we have equals E. That's not alphabetical. Make it alphabetical. B, E, D. Huh. I don't even know what alphabetical means anymore. There we go. Whatever. Okay, so that's the setup. Now, step 1 was to cancel the fraction. Step 2 is to factor. So here I'm going to factor out the thing that both of these things over here have in common. They both have x in common. So I'm going to factor out x. giving me no fraction, but a pair of parentheses with stuff in it, and x on the outside. X times AD plus BC, and it equals BDE. A lot happened there. I realize, I get it. We did a lot of that with the numbers over here, and that arguably should appear easier. Experience tells me that that side would appear easier. That's why I did it first. But over here, I want to now take those steps. Step 1, multiply everything by the denominators. Step 2, factor out. Step 3, divide. It just looks gross because there's a lot there. All of this is multiplying x. Cancel it out. There you go. We're done. I mean, it's gross, but it works. So x equals BDE over AD plus BC. Call it done. Okay, let's check what we're doing. Save this. Taking a while to save. I hope that you understand the process, though. The process being you have written stuff in that you have distributed and factored and divided, and it's still a 3-step problem. It's just along the way, each of those steps does get more complicated, but you can do it. You're in high school. It's what you should be expected to do. Let me see here. Closing. Absolutely. We covered the tough tickets, the tough ones you got to do. My last comment is one that's going to pop up, and it is right here. How do you solve for something when it's squared? And we haven't done any problem like that, so I'm just going to make sure that I show you that when you get, yeah, why not? Let's just do it. You need to solve for A, but I'm going to solve for T. Okay? So in my first step here of solving, my first step is going to be to cancel the 2, the fraction, multiply by 2. So I get 2v equals AT squared. This should actually be your first step as well. Where we deviate is that I'm going to try to get t by itself while you're trying to get a by itself. So I'm getting t to be by itself. A has to go, leaving me with 2v over a equals t squared. How do you get the t to become its own thing? Well, the opposite of square is square root. So square root, both sides. T is now by itself because squares and square roots cancel, but on the other side is a square root. So the answer, survey says, flip it around because why not? 2v over a square root. That's my answer. You still need to solve for a, but I solved for t. Solved for t. And I could argue there's more stuff I should tell you about this, but I'm not going to do it yet. Okay. Please make sure that you finish this lesson, do the problem set, get some help if you need it, watch and rewatch and ask and check in and do everything. I always say do these 4 things, or I have started to make sure that I'm clear about saying these 4 things. 1, check for hints if they're available online. 2, ask me. 3, ask a friend. And then 4, go back and watch the video again and again and again. Common thing in mathematics is to not get it the first time around, but with perseverance, you can be successful. All right, that's lesson 10, day 4, into the section. We're going to talk about solving inequalities next. Like and subscribe.